All right, so what I did is I just built the circuit that you have on that diagram. Now, I'm going to show you a couple of options on how you can do these depending on how organized that you want to be, okay? So, kind of up there on the step, up there above, I kind of say, hey, this is some helpful things to remember. So, right, for now, all the circuits are going to be the same, and those are all going to be 10 ohm resistors, okay? So that's 10 ohm, that's 10 ohm, and then that's 10 ohm, okay? So we'll make it simple. So on these, the first thing that you need to be able to do, and if this is wrong, literally everything else you're going to do is going to be wrong, is that you have to find what we call the equivalent resistance of all of the resistors in the circuit, okay? So, you've got two 10s in parallel, which would be equivalent to what? 5 ohms, because it's 1 over 10 plus 1 over 10. So this right here is the equivalent, those two resistors in parallel are the equivalent of having one 5 ohm resistor, okay? But then that's like having, here's kind of the leap of faith that you have to have. So that's like saying I'm going to have one 5 ohm resistor in here hooked up in series to a 10 ohm resistor. So the equivalent resistance is going to be what? 15, okay? So those three resistors, two in parallel, one in series, having a value of 10, is the equivalent of just having one big 15 ohm resistor, okay? So that's kind of where you need to start. So on the chart, okay, and some people like this chart because it keeps them organized, okay? You don't have to draw the chart, but if you get deep into the woods and you're going, man, I don't know what to do, okay? Charts are wonderful things. So, here's the story. Let's look at the whole big picture. If we have one 15 ohm resistor, the equivalent of one 15 ohm resistor, hooked up to one 30 volt battery, so that's a 30 volt battery, okay? And I have one 15 ohm resistor. What should be the current in the circuit? 2 amps. Because if I take the 30 volts, divide that by the equivalence of the 15, I should get 2 amps. Miracle of miracles, I got the 2 amps, okay? So, I got 2 amps coming into the parallel section and then coming out. Now, this is the actual path. If you want to have like the conventional one reverses that and it shows it coming from the positive terminal. Now, usually, like if you're taking the AP test or like on my test or anything, if I tell you to talk about the current, unless I specifically tell you to worry about the movement of the electrons, you assume that it's the conventional idea of the current, and in this situation, that's going to be moving clockwise from the positive terminal around. So unless you are specifically told differently, you assume that it's the traditional Ben Franklin version of the current. If I want you to think of electrons, I will tell you to. Otherwise, it's the traditional version of the current. Okay. So, at this point, let's talk about the voltage, okay? So, I got a 2, and there's a couple of different ways you can think about this, okay? I'll show you both. How you tend to think of it, I care not. So, this is a 30 volt battery. If I were to measure the voltage drop all the way across from that first resistor over to where it joins up over on the other side, way over there on the other side of that parallel circuit, what should the voltage drop across everything be? 30. Okay? So, let's make sure that works like it should. I got that. Oh, it's negative 30. okay? So I have a 30 voltage drop across the entire thing. Now I've got to figure out what's going to be the voltage drop across each individual one, okay? So let's start with the first one. Now again, you can VER it up. What's the current going into that 1 ohm or to that 10 ohm resistor?
2 amps.
That's going to be 2 amps. Okay, so my current, that's my I value, is going to be 2. What's the value of the resistance? 10 ohms. So if I VER it up, I'm going to get 20. And so if I do that, boom, I got 20. Okay? If you like ratios, basically what we're saying, some people like to think of this in terms of almost like a percentage. And going, okay, well, that's a 10 ohm resistor out of an equivalent resistance of 15. I've got a 30 volt drop. As a ratio, that's going to work out to be 20 volts. Okay? Some people like ratios. Or if you just want to VER it up, I don't care. Now, this is where it gets a little bit more difficult. The first one is going to be fairly simple, but it's going to get more and more complex. So, when you talk about the voltage drop across the two that are in parallel, okay? So, this first one is 20. Voltage has to add up to whatever you started with. I can't create voltage. So here's the question. We just said the first one was 20. So here's the question for the other two that are in parallel. Are the other two in parallel going to be 10 each, or are they going to be 5 each?
Have to be 5 each.
Why?
They're both 10, then they add to 40 volts and it would make any sense.
Okay? So, but they're in parallel though. Okay? Just keep that in mind that they're in parallel. Okay? So, here's the story. Again, there's a couple of ways you can do this. One option is that you look at this as a ratio and go, okay, this is 2 amps coming in. Since both resistors are the same, okay, both resistors are the same, and they are, and I have 2 amps coming in, what's going to be the current going to each resistor?
Get that loud.
Yeah. Don't worry about it if you don't get too far. We're going to finish it up tomorrow.
Okay. How far should I get? Just
Maybe kind of the beginning of that first one, about halfway through that first page.
first page?
Yeah. Okay. So if I've got 2 amps coming in and I have 2 equal resistors, what's going to be the current going to each one? 1 amp, right? Don't believe me? Miracle of modern technology. I get 1 amp there. I got 1 amp there. Okay? So if I VER it up, okay? If I VER it up, I have 1 amp going into a 10 ohm resistor. I get 10 volts, right? Because it's in parallel. So both of those have to have an equivalent drop of 10 volts. So it doesn't add, you sit there and go, well, that adds up to more than 30. But each one has going to carry the same voltage. That's the beauty of parallel. Because if I just had one 5 ohm resistor in there, that would then carry that same voltage of 10. Okay? So since it's parallel, you have the same voltage drop. Okay, so if you look on this chart, so your voltage on 1 is 20, 2 and 3 both have 10, and you sit there and go, but that adds up to more than 30 because it's 20 plus 10 plus 10. But what you have to remember is in parallel, they have the same voltage drop. Okay? So if you look at the current, you got 2 amps going into the one, the other ones are each 1, and your resistors are all at 10. But the equivalent resistance is 15. Now we're gonna change it up. We'll make it a little bit more complicated. Because we can. So,
Indeed.
okay. So, now I've got 10, 5, and 20. None of them are the same, okay? But the same mathematical model is going to happen. So it's the first thing that you have to find.
Total
The
resistance.
equivalent resistance, right? So somebody, that's 5 and 20. So somebody take 1 over 5 plus 1 over 20,
4,
and then add that to 10.
G, 14.
You get a total of 14. So this part up there has a resistance, equivalent resistance of 4. This one there is 10, so the total is 14. So how can I find the theoretical current in the entire loop?
Voltage over
30, take 30 and divide it by 14.
2.14.
What'd you get?
2.14.
2.14.
C.
And oddly enough, I get 2.14. Cool, okay? So, let's talk about the voltage drop. So, if I have, and I do, a 21.4 or 2.14 amp here going into that 10 ohm resistor, that should have a voltage of what?
12.4.
Andrew? I got a 2.14 amp current going into that 10 ohm resistor. Voltage should be
21.4.
21.4. Just multiply them together. I check it. Andrew did not break physics, and it's 21.4.
How do you know?
Well, at least on this model it didn't, okay? Not yet, I'll give you another chance.
Just wait till
All right, now, this is where it gets a little sketchy on how you want to do this. It really isn't sketchy, it's just a matter of perspective. So, it's whether or not you want to kind of think through it on a couple of different levels. So, you've got 5 and you've got 20. So here's what you can do. And what was the current going into? 2.14?
Yeah.
Okay. So, this is a method that I like because it's more mathematical, okay? So, going into here, you have a 2.14 amps. This is going to get split. So, here's the question. Jaden, which one is going to have more current? The 5 ohm or the 20 ohm?
5
Why?
as least resistance.
It has least resistance. It's going to be easier for the electricity to flow through the 5 ohm. So I know that the current going through that one is going to be bigger than the current going through the 20 ohm. Now, it's going to work out as like a ratio. So here's what I do. I take the total current that's flowing into it. So if I want to find the value that's flowing through the 5 ohm, what I do is I take the 5 ohm, okay? That's what I'm looking for. Then I divide that by the total value of the resistance that's in those two parallel resistors, which in this case is going to be 25. But here's what I can't do. I can't take 5 and divide it by 25 and multiply that by 2.14. Because if I do that, then if I take 5 over 25 and multiply that by 2.14, that would tend to indicate that the 5 ohm would have the lower resistance. Or excuse me, would have the lower amount of current, when in fact it's the bigger amount of current. So what this does is, this is why I take 1 minus that ratio, and then multiply it by the 2.14, okay? So it takes into account that this is a proportional value, by taking 1 minus that allows me to go, oh, this is going to be the bigger current, okay? So if you do that, you get 1.71, and then you get 0.43. Now, theoretically, if you're willing to roll the dice, as soon as I know one of them is 1.71, automatically, how could I find the other one? Subtract it out. So if you want to shortcut the process, and I don't recommend this, you could just say, oh, well, that's 5 out of 25. Take 5 out of 25, multiply that by 2.14, get a number. Then go, okay, then decide, is that going to be the bigger current or the smaller current? Okay? That's an option. You're rolling the dice, big dice to roll. Because if you screw that up, then you're going to screw up all of those calculations going forward. But if you do this separately, and then you get the numbers, and then you verify that it adds up to 2.14, that's a safer route. Because then you know, okay, I know I did this right. I can look at this and go, clearly the 1.71 is going to be the bigger current. The 0.43 is going to be the smaller current. It works conceptually, and it also works mathematically. Okay? It's personal preference what you do. This is just what I would do, but that's just me. Now, we still haven't settled the voltage issue. So to settle the voltage issue, at this point, here's what I know. I know going into the 5 ohm, I have 1.71 amps, and I have 0.43 amps going into the 20. How could I find my voltage using those numbers? Vert it up, okay? So at this point, if I know what my amperage is, and I know what my resistance is, all I have to do is just multiply them together. So, somebody take 1.71 times 5.
8.57.
8 point what?
57.
6.
Okay.
8 point what?
8.6.
5, 6?
8.6.
Y'all are battling me over one digit.
Yes, and
Is it 8.57 or 8? When you say 8.6, is it 8 point, are you saying 8.6 or 8.56?
8.60.
They're just trying around it. It's the same.
I'm trying to get.
We're good, let's just
ruining
leave
the
that.
fun.
So what's going, then, so then, what do you got going through the 20 ohm?
The same thing.
Because here you've got a smaller amperage, 0.43 amps, but you have a bigger
Resistance.
resistance, and oddly enough, if you do that, you still get 8.57. So now, if we go back to the program, our regularly scheduled program, if I go in here, let's round it, I get 8.57 there.
I don't like that number.
and I get 8.57 there.
That's a bad number.
Now, here's the question. Is 8.57 and 8 point, so these are both gonna be 8.57, right? But this one's going to be 21.43. What should they add up to?
30.
30. Okay? But your parallels, even if they're different, still carry the same voltage, even if they have different resistors. Okay? Got that? So I wanted to do that kind of as a guided thing to make sure everybody's cool with where we're going. Okay, stop yonder camera.